Hey, what is going on? It is April 1st, 2022, Friday, April Fool's Day, and so I'm not going to do anything today. I give up. I decided to quit coding, and I'm going to become a logger working in the forest. Okay, so um, no, it's April Fool's. I'm not going to do anything of the like. Today, I've decided that I'm going to do a simple problem for you, and that's the intersection of three sorted arrays. This is a bit of a classic problem, classic coding problem, and it's solved. Solved through, I would say, some basic means. So how do we solve this problem? Okay. Um, okay, there's two ways. There's a fast way and a slow way. But let's go through the most intuitive way to solve this problem, and at some point we can talk about a faster way. So the most intuitive way, um, I think. Let's look at the problem statement first and then decide. Given three integer arrays AR1, AR2, AR3 sorted in strictly increasing order, return a sorted array of only the integers that appeared in all three arrays. Okay, so AR1 is 1, 2, 3, 4, 5, AR2 is 1, 2, 3, 1, 5, 7, 9, AR3 is 1, 3, 4, 5, 8, and your output is 1 and 5. Okay, because 1 appears in all three arrays, 5 appears in all three arrays. Okay, in this case, for 197, 418, 523, 876, 1356, 501, 880, 1593, 1710, 1870, and this next array, none of the integers appeared 3 times. Okay, so so one thing to consider. Let's read the problem statement. Let's look at some pieces. The arrays are sorted in strictly increasing order. So sorted is bold, and strictly increasing is bold. So both of those are important to solving this problem. Okay, the strictly increasing to me means that there's no duplicate. Okay, sorted also has implication in terms of optimizations, I think, and return a sorted array. Okay, so let's start with the version that I'm thinking. So this should be the most straightforward version, and then in another video I'm gonna maybe go into the less straightforward version. So in the most straightforward version, also where possible, I like to, I'm going to use a map, right? A map to count the frequency of all the elements in the array, okay? So where possible, instead of using a hash map data structure, I use a frequency map. Frequency maps are usually a lot faster than hash maps, and it can vary depending on the problem. Perhaps in this problem it will be the case, but there's overhead in the hash map that can, in accumulation, make it slow. But the reason I can use this frequency map is because the value of the elements in the array according to the constraints is less than this amount here. So again, a hash map would be more useful if this value wasn't constrained and you had the entire huge set of integers to deal with, because then this would have unnecessary space in it. So we have this count array. What do we do? So basically we want to loop through each of these we want to loop through each of these arrays. We can do this simultaneously to save time, so we don't have to naively iterate through each array. Again, that's still linear time if we iterate through each array independently, but we don't want to do that because even linear time has optimization implications. It could be slower to do this back to back if we just need to do it one time at a time. So now these ORs let me know to make sure that I can loop through each of these arrays without crossing the boundary of any one. I'll show you what I mean in a second. If you're not familiar, if you are, then kudos to you. If you're not familiar with what I mean. So first, so all we do is, so for each index, right? We have 3 indices. If we find first of all, if the index is less than the length of the array, which is necessary to show that we're not at the bound of that array, then we just increase the count. Okay. And then we check if the bound is, okay, we check if the bound is, we check if the total count of that element is 3 at this point. Because if it's 3, by the time we get to any one of these arrays, then we know that it's found in all 3 arrays, because again, sorted in strictly ascending order means there can't be duplicate. If it's sorted in ascending order, then there would be duplicates, right? I guess you can also say strictly ascending could mean no duplicates, but I mean, in this problem, that's what it essentially means. Again, that there are no duplicates because the array is strictly ascending itself. Strictly means it's every element is strictly greater, not greater or equal to every element before it. AR2 length. So we're going to do the same for each element, right? And I'm only writing this out because this is the same piece each time, because we can, compress this code, but it just, it helps with the programming muscle to write out stuff. But again, yeah, we can make this even more optimal by sort of iterating through each of the arrays and pointers. Unnecessary. And actually, we don't even need 3 pointers, I think. We can just use 1 pointer. Okay. Okay, let's try 1 pointer. I is less than. Okay, let's try 1 pointer, because we can use the 1 pointer to kind of iterate through everything simultaneously. If I is less than AR3 dot length, count AR3 I is plus, and see, if I was just copying each of these dumbly, then I would have missed that I'm making a mistake with these pointers. Eventually I would have corrected it, but better early than later. That add AR3 dot I. Okay. Alright, and then return result. Okay. Now I believe this should work. Make sure I don't put any extra brackets. Okay, and let's try running it. And bam, that was actually damn fast. Wow. Okay, well, yeah, okay, that's cool. And obviously I've experimented with different versions of this in the past, but yeah, that was actually the fastest run I've had, I think, for this. Okay, so it's worth copying that. And yeah, so that's it. Next time I will show you the more efficient solution, but actually this is pretty damn efficient, it looks like, as it is. Okay, so thanks for watching. Like, subscribe, comment in the link below. Let me know if I can do anything better. One thing I will remember to do is tell you the runtime of this. The runtime is O of n, the space is O of n, because I'm using this map, right, to keep the count. Well, actually this map space is constant because I'm using this count map. Okay, so I'm always using the same amount of space, And in the constraints of this problem, this is fairly optimal because this is a tiny amount of space. Okay, so yeah, that's it. Thanks a lot, and I'll see you around.